everyone, welcome to another day of live LeetCode coding. I know I was fumbling around a little bit there with the time settings, but we're on at 5 p.m. Eastern, and I'm glad I was able to do it. I was just wrapping up something at work, so I'm really happy that I was able to finish that. And now we're on our way to doing some more LeetCode. So happy Friday, everyone. Hope everyone has had an awesome day. It's been a very productive week for me, so I'm excited to wrap it up with this last stream for the weekday before moving into our weekly roundup for tomorrow. It's been a very good week. We've gone through a lot of very good questions. And again, we passed our 200 question mark, which is very neat. Now I'm just looking forward to 300. And before you know it, we will be getting to that 591. Probably by the time we get to 591, we would have already done over 600 questions because let's see, I think when I started, this was like 580 something. So it's gone up a little bit, not a lot, but for 200 questions, it's gone up for maybe like 5 questions. So some housekeeping things like I always do. So remember, if you like what I'm doing, if you want a way to keep track of your progress and do some of the questions that we've covered here, you can visit my website at rafaelislist.com. You can look at different topics for all the different questions that we've talked about on the stream. And you can also search for any existing question if you find one on LeetCode and you're curious to see if I've actually done it. You can also even keep track of your progress. You can click on the stream clip link here to be taken to the chapter in the stream where I actually did it. So yeah, hoping that that helps you all retain or stay accountable. I know it's tough, but we're all in this together. And let's just go ahead and start. Hey, Rashawn, glad to see you again. Always good to see you. I think out of everyone that's joined, you have been the most consistent person on the stream. So thank you so much. Again, I think I've told you before, but you're like one of the OG members of this stream. So very cool to see familiar faces here. Hope that your Friday's been awesome. Hope that you and your family are doing well. And let's just go ahead and resume from where we left off yesterday. So let's see, did I do... I feel like something, oh, this is why. I need to do easy algorithms by acceptance just to make sure we're on page, okay, we gotta go to page 3. All right, so we left off in calculate amounts paid in taxes. We're gonna start off with surface area of 3D shapes. It sounds a little bit intimidating, but let's see. We're given an n by n grid, so we know it's a square, where you have placed some 1 by 1 by 1 cubes. Each value of v equals grid of ij represents a tower of v cubes placed on top of cell ij. After placing these cubes, you have decided to glue any directly adjacent cubes to each other, forming several irregular 3D shapes. Return the total surface area of the resulting shapes. So this one, I think I understand what they're saying, but I'm trying to figure out how, is this just like, okay, I was wondering if maybe it was just like multiplying all these numbers, but I guess not. The bottom face of each shape counts towards its surface area. Oh, so does that mean, I think, let me see if I can like picture this in my head. Okay. Yeah, if we draw this, it'll be a little bit clearer. This is a little bit tricky to like get in your, or like to picture it in your head. You have to have very good sort of like, what's that called? What's like the ability to like see things and like change them in your head? I forgot what it's called. Not space-time. No, not space-time. Definitely not space-time. So if you imagine there's like, can we draw this? Is there an easy way to draw this? We have like a rectangle that's sitting on the bottom here, and that's just like one. If I do this myself, we'll have like, yeah, this is tricky. I get what they mean though. I'm even having trouble describing it, and I don't even know how I would begin to draw it. Something like, if I'm looking at this from the top, yeah, there's no like nice way of doing this unless I attempt to make like a 3D figure. But that's just gonna be like man, has LeetCode become like art? Like LeetCode is art now. You gotta be an artist. I don't even know what I'm trying to do here. Like, I think what they mean, and it's also going to be hard to even like draw a cube. Can I fill this in? It'd be nice if I can fill this in. Oh, background. Like, no, I don't want it to be transparent. Background. Okay. And then we have like 2 here. And then I guess we have like 3 here. But then now we're going to be blocking this one. Does this even make sense if I draw this? Because I can't change this. But I think what they mean is like, okay, let's focus on the back. Focus on the back one real quick. You know what I should have done? I should have, I hope I'm not wasting too much time doing this. Maybe this is just not a good question. But really what I'm thinking is like, you take each one of these. It'd be nice if I can move this to the back. Let's say it kind of goes like here, and there's another one here. Okay, so even though it looks like there's a space in between these, imagine there's not. So like if you consider this one right here, this forms a rectangle that's like 2 blocks in length and 1 of height. So I'm guessing the area of that is what, 2? Right? And then on this top one right here, we have like these connected. And then but then what does that do? Does that just gives us an area of like 2 by 2, which is 4? So what, this becomes 6? And then for this 3 up here, how does this one work? How do we get our area from this 3 by 3 and then 4 by surface area of 3D shapes? Several irregular 3D shapes. Total surface area of the resulting shapes. 1, 2, 3, 4. 1, 2, 3, 4. This is just backwards. 1, 2, 3, 4. So yeah, we'd have something that's like, can it be as high? This is very hard to like wrap around in my head. I don't even know if this question is like worth doing. This seems to be like more geometry and less about data structures and algorithms. So I think I'm gonna skip it. I'm happy that we maybe got to draw like kind of a cool image perhaps, but I think that's about all we gained from this one. I don't think this one's worth it. And I think the like to dislike ratio says as much. So we're gonna continue on. We're gonna go to reshape the matrix and we'll see what this one has to offer us. Okay, maybe this one's better. In MATLAB, there's a handy function called reshape, which can reshape an m by n matrix into a new one with a different size r by c, keeping its original data. You're given an m by n matrix mat and 2 integers r and c representing the number of rows and the number of columns of the wanted reshaped matrix. The reshaped matrix should be filled with all the elements of the original matrix in the same row traversing order as they were. 1, 2, 3, 4. Okay, so I think what we can do... Yeah, okay, I understand what they want us to do here. Here we can just, yeah, on to the next, exactly. Like that other one really was not worth it. I think what we can do here is, I think we're going to have to traverse the input array, in this case mat. And really what we need to do is we just keep track of the columns. We fill in as many columns as we can. That becomes a row that we push. And then I think the main thing that matters are the columns. I don't think we necessarily need to worry about the rows. Row 2, column 4. Oh, but I see. But we're also bounded. So I guess whichever one comes first, even though they're saying that we want 4 columns, we want 2 rows though. So I guess whichever one comes first. And I guess at either point, that's the tricky part. Like as we're going through this, we say, okay, we have 2 columns, so we can put more columns, but then if I continue going this way to make it 4, that's just going to equal 1 row, right? So how do we know? Let's see, we have 2 things. We have 4 available, but we want 2 rows. Here we just want 1 row. So maybe the row should just be determined by, and we have 4 things inside of here, but we want 2 rows. Is there like a nice formula I can use? Like, which one of these takes precedence? Right? Because what I was thinking about doing is going through 1, 2, 3, 4, always traversing that input array and using these to our advantage. We're going to have to like generate new rows every single time. In this case, row is 2 and C is 4. If I traverse through all these and I say, well, I counted 4 grids, that equals 4 columns. If I only make a new row at the end, though, I'm still going to be left essentially with the same thing here. Same thing that I have up here. So why would I stop here and say, well, I'm at column 2, and this is a square, so does that mean that maybe these will be like divisible? 4 divided by 1. Maybe we take the amount of columns divided by the amount of rows, and that's how many things we need in each column. Could that be like column count equals column divided by 4? Does that even make sense? Because what if it's 4 rows and 1 column? Right? If it's 4 rows and 1 column, actually that would just give us the same thing. 4 rows. Well, no, 4 rows and 1 column. What's the C is less than 300, R is greater than or equal to 1. Output the new reshape matrix, otherwise output the, and what does it mean that it's legal? Possible and legal. Otherwise output the original matrix. Oh, and it's also not an m by m matrix. It's not a square. And how do we even know? Yeah, like I really just want to do this in one pass. But this is where I'm struggling right here. Because if I have 4 columns, why wouldn't I just continue on? Why wouldn't I just continue like after the 2? Like, why would I stop? Is it because I say, well, I need 2 rows and I have 4 of these, but is it always going to be the case like they won't always be divisible? Row 1. Four columns. This one's tricky. Frankly, I'm not even sure where to start with this one. This one's like really stumping me. Even if I don't even know what I would draw exactly, but if I have, whoa, nope, wait, get rid of all that. If I have something like this, 1, 2, 3, 4, and if I somehow start, oh wait, no, I don't want to do that. Even if I start like here and then move 2 rows and 4 columns, maybe when I get to the end, maybe it's more of a thing of like, well, I'm at the end of this row, but I can still, that doesn't really matter though, because we're putting it into a new grid anyway. Unless we just create the new grid first. We could do that. I could create the new grid first. Row 2, column equals 4. But then if I created a 2D array, with row 2, column 4, then I'm going to have like empty spots. Row 1, column 4. I go on row 0 and I place it in row 0. I'm still in row 0, column 1, place it in row 0, column 1. Then I get to row 1, column 0. Really stumped on this one. Frankly, I don't even know where to begin here. Mostly for the sake of time. I hate to say it, but normally with these streams, like only because we're, let me just backtrack here a little bit. Because we're, like if we were at like 580 questions, I might take more time. Like there's going to be probably like 30 questions at the end that are just going to be the hardest, easy ones to do, or the most annoying ones that I'm just going to have to spend a lot of time doing. But now, since we're still like less than half of the way through, I want to try and fly through a lot of questions to get you guys the most value. And then towards the end, we can spend more time just filling everything out. So unfortunately, I think I'm going to skip this one again. And now we'll go to valid anagram, which everyone knows this question. It's a very good question. And I think this is a top tier question that's a lot of times on these like grind 75 or LeetCode IO, blind 75 lists. I think this is one of like the best ones to do. So let's look at this. Given two strings, s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Now, a couple of things that we can do here. So it says already that s and t consist of lowercase English letters. So you might be tempted to use an object literal to keep track of the frequency of these different characters, but we can actually just use like a static sized array. That way the space-time remains constant. It doesn't matter the size of s and t. Also, one very clever thing you can do is we know automatically that we cannot make an anagram out of two strings if they're not at least the same size, right? And we're guaranteed to at least get a string of size 1, so we don't even have to worry about the empty case or the null case. But we can immediately say that if s.length is not equal to t.length, we'll just go ahead and return false immediately. Then we can go ahead and create our frequency array, and we'll make this new array size of 26. We'll fill this up with 0. And then for the first one, we can say for const c of s, so c here means like c for character. I'm going to grab the index, which is going to be normalized. What I'm essentially going to do is I want to map every single character to its own index. And at that index, I'll keep track of the frequency. And I normalize it because I want, for example, A to be 0, B to be 1, so on and so forth. And to do that, we can do c.carcode at 0 minus 97, because 97 is the value of the lowercase letter a in the ASCII table. So once we get that, we can effectively increase the frequency at that index, so frequency index plus plus. And now we can start going through t, and we can say for const c of t, we'll do the same thing, const index equals c.carcode at 0 minus 97. And what is it that we want to do? We want to immediately say frequency at index minus minus, and if frequency of index is less than 0, we return false, right? Because that means we used up one more character than there was available, so now we're in negative territory. Else it would just remain at 0. And at the end, we can just return true. Now, there's a way, let's actually just run this for all our test cases and see what we get. So true, false, let's run this. 77.77, look at that, all lucky 7s. It's like the roulette going down. Let me also make sure everything's looking good here, right? So let me check this real quick. Like the nice. Okay, so one other thing that you can do that you might see a lot in LeetCode is you can put this check inside of this if, because what you're saying is you're checking the frequency after you've decremented, right? So what you can actually do is you can say negative frequency first, because what this does is it will first decrement the frequency at this index, and then it will do your check. So this is called like a prefix operator, versus you might see it sometimes like this, a postfix operator. In this case, we actually check the frequency first and then we decrement the value. We want to decrement the value first and then check for the frequency. So let's run our code again against our test cases. True, false, true, false. We'll submit this and we get 99.37. So a very, very great question. I think everyone should know how to do this. It gives you a lot of, I like all the different things it teaches you. Like for example, this is a very clever trick, understanding your constraints to try and do things early and potentially save a lot of time of even having to do any of this stuff. So I think this is one cool trick. Of course, one of the more popular ones is this right here, to be able to construct a fixed size array to keep track of our frequency instead of creating an object literal, which would be dynamic. This allows the compiler to actually make some optimizations, and this way we just save on time. And finally, this prefix operator, which I like a lot. It makes your code a little bit more elegant, and I think it's still easy to read, which is cool. Now the follow-up right here, what if the inputs contain Unicode characters? How would you adapt your solution to such a case? What you can do is you can still create an array of some size, but I think Unicode characters, how many what's the like Unicode, is there even like a Unicode table? It's like what, 65,536? You could potentially create an array that large, I guess. Or I think something else that's really good is, let me see, size. I think it's 65,000. Yeah, 8-bit and 16-bit. So if we do 16-bit, what you can do is essentially you can create a mask. You can create like a bit mask of 65536, and then you can essentially use that to store. You can like toggle bits on and off, and you can see if you've already used like a certain number. And I think you can do the same thing for like 8-bit too. So just another kind of an interesting way to think about Unicode for this question. So yeah, this one's really good. Let's go ahead and like this question. I'll be adding this one to my website afterwards. I think it's awesome. So sweet. Maximum number of balloons. Given a string text, you want to use the characters of text to form as many instances of the word balloon as possible. You can use each character in text at most once, return the maximum number of instances that can be formed. So I think this is what I'm thinking so far. This is the first thing that comes to mind. Like, imagine we just had a count. Let me see. Oh, the hard thing is that it's, because some of these are duplicate, right? If it was all unique, it would be nice. But it always needs to be balloon. So I'm going to use that array. I'm going to use this to keep track of our frequencies here. So we have 1N, 1L, 1A. We have an E that doesn't matter. We have a B. We have an O. We have an L. So we have two L's. We have a K that doesn't matter, and we have O. Right. So this is what we need. So I think what we can do. Let's think about this. How can we make it so that, like, I want to keep a track of all the different, let me see, balloons. How many balloons can I make? The tricky part is are the L's and the O's, and so those are duplicate. How do we account for those? But I think we can do something here. Just let me think about this for a moment. Let's see what our constraints are. Text consists of lowercase English letters only. Again, that's a good way to keep track of frequency. We can use that static sized array. Now, if I have the frequency of all these letters, I guess I'm just gonna need double for my L's and my O's. So I mean, I can take the maximum of, like, for example, let's say we had like 4, 4, 4, like given just these, and since these are single, right, we can create a maximum of 4 if I have, or let's actually do this. I'm going to abstract this a little bit. From the single ones, right? Forget about L and O since those are duplicate, but from the single ones, if we had 4, 5, 6, by the time we get to like any of these, we're essentially capped by the minimum one, right? Even if I have 6 N's, I only have 4 B's, which means I could only make 4 instances of balloon. So I think that's what we can do with, we can say like get the min of the single letters. Now here, let's think about this. If I had an odd number here, what would happen? I have 3 L's and 2 2's, so I can create, would I just divide it here? And would it still be the minimum? So 2 divided by 2, that's 1. 3 divided by 2 is 1.5. So I'm capped by the minimum of whatever that value is. So even if I had 6 here, 6 divided by 2 is 3. And then 2 is 1, so I can still only make 1. Right? Or not 1, but we'd be able to make what, 4? So would that be it? Because we can do 4 balloons. No, I guess it would still be the minimum of any of these. Because if I only had 1 O, I could only make 1 balloon. You can use each character in text at most once. Return the maximum number of instances that can be formed. I think maybe we can do that. It's always the minimum. If I only have, well, what happens if they only give me, like, yeah, what happens here in LeetCode? Because here in LeetCode, I have 1L, 10. Okay, but what if it was like LeetCode or something? Like if they gave me LeetCode, then I would take the 2, like the pair here, and I would say, oh, I can make 1 because I have, but then I don't know that I actually have any of these. Does that make sense? I hope that makes sense. I hope you guys understand what I'm trying to go for here. Form as many instances of the word balloon as possible. Or maybe there's another way that we can do this. If I gave, I mean, we could like, no, I don't think that would work. I was gonna say like create a string every time, but you can use each character in text at most once. Maximum number of instances that can be created. 4, 5, 6, 6, and 2. If I have 1B, 1A, 2 L's, 2 O's, and 2 N's, how many of that configuration do I have? Can we just count all of them up at the end? Let's do this example because this one's like, this one might actually be better. So this is the word. Let's go ahead and let's get the frequency of all these. So we have 1L, we have 2 O's, we have 1 N, we have 1 B, have 1 A, we have another L, we have an X, that doesn't matter, we have 2 B's, we have 2 A's, we have another 2 L's, so that's 4. P doesn't matter, we have another 2 O's, and then we have 2 N's. Okay, so we have 2, 2, 2, 4, and 4. So yeah, we can do 2. So what can I start saying here? I can say, well, so far I can make at least 2. Okay, so far I can make at least. Now why here? Like what would I do here to kind of keep that trend going? Because if this is 1, do I just immediately say, well, I'm capped by the one I have? But what if I had no zeros? Or what if I had no B's? Right? It wouldn't be. Well, I guess the answer would just be, oh, I guess we would just keep track. I guess we would always just keep track of the minimum. And that wouldn't necessarily be, it can never be greater than the minimum of any of these. If that makes any sense. Like if this is 1, then that means I could only ever make 1. I think maybe we can do that. So let me try some now. Let's say const frequency equals, let's see, const frequency new array of 26 dot fill 0. For const c of text, going to do the same thing we did in the previous question. C dot car code at 0 minus 97, and then we'll say frequency of index plus plus. Now what we can do, I think what I can do is I can say for const c of text, I'm going to go through it again. Let's see, let min equals, I'm going to make this a large number, right? If c is equal to b, or c is equal to a, c is equal to, oh man, why does it keep, oh actually we can do a little bit better here. We can do ban dot test c. This will just be an easy regex, right? We're just saying like if the letters in any of these, case insensitive and global, well I guess it's lowercase letters anyway. I'm gonna try it without this because this might still work. So if it's this, that's one case. Else if here we have an L or an O dot test c. We're going to do different things. So here, this would just become, yeah, min equals math.min of min, or, yeah, we're still going to need our index here. Const index equals c dot car code at 0 minus 97. Inside of here, I'm still going to need to do the math.min, or we can say frequency of index. This is for the ones that only appear once. Now, if it's not, I think we should get, what's the min frequency? It's going to be min equals math.min, again at min, or math.floor of the frequency at the index divided by 2. So the min here is 1, so we can only ever create at most 1. Now, however, this is where it becomes difficult, because if I have 0 of the rest of these, the answer shouldn't be 1, right? Because I don't even have any of the other letters. If I'm just given the letter B, the answer should not be 1. That's where the issue comes. So I don't think that's going to work. Yeah, I don't think that's going to work. I need to make sure I have, yeah, I still need to make sure I have at most 1 of all the other ones. There might be another way of doing this that I'm not seeing. I kind of want a way to like keep a count of only these unique letters, and then whenever that reaches, we could do that, I suppose, but that's gonna make things tricky. Well, we're getting some hard questions today, or maybe I'm just not able to think right today because it's been a pretty hectic day. But maximum number of instances that can be formed. Like, you're given a string, how many instances of the word balloon can you find in that string? Okay, how do we do that? Well, we keep track of the frequencies of all the letters, and based on the ones that we care about, how many letters can we extract? I mean, can we keep track of... I mean, one way that we can do it, and actually, you know what we can do? What if we create a frequency table first, and then we just loop through the balloon like many times, and any time that we're, okay, so let's like forget about this. This is what I'm thinking, guys. So imagine we have our frequency now, right? Our frequency, and we have the frequency of all the letters. Now, let's say let min equals 0. Can we do, what do I want to do here? I want to loop through the word balloon like many times. This is not going to be time like efficient at all. I know it's not going to be, but it's like the only way that I can think about right now. Yeah, I think I just want to do like while true. Anytime I see a while true, it scares me. For let I equals 0, and I guess balloon. Let's say let search equals balloon. I less than search dot length I plus plus. What we can do is we can find the frequency of the thing at this index, but then like for each one we have to subtract 2. And I guess as long as we subtract 1 or 2 and it's not less than 0, we can continue going in our loop. That even to me that doesn't really make sense. So let me try and write this out. What's the first thing I want to do? I want to get the index of this character. So const index equals search of I dot car code at 0 minus 97. Here actually I'm gonna need the same thing, and I'll show you what I mean. I'm gonna remove all that. I'm gonna stick this in here because I still want to check to see. We can say if ban test of search of I test of search of I. Okay, so here what I can do is we can say if we're looking at a ban and if negative negative frequency, let me see, frequency of index less than 0, here we'll just return min. And over here, I'll say if, I'll do it a little bit differently. I'll say frequency of index minus equals 2. And then I'll just copy this and I'll say if frequency of index is less than or 0, return min. And at the end here, we'll increase it by 1. So like, what am I doing here? Okay, we have this while true thing, right? So I'm going to be looping through balloon multiple times. Every single time I start from the beginning, right? And I have this array of frequencies. I get the index of B, right? Search of I. So this is B. I do the same thing. I normalize it so that way I can look inside my frequency. If it's a B, an A, or an N, that's what I'm doing. I'm testing that regex against the current character, right? If it's a B, A, or N, I'm only going to subtract 1 from index. If that's ever 0, right, then I can only return, well, if that's ever 0, then I just immediately return min. Let me see though, is that gonna work though? Min is 0, else if, no, this might not work either. If I get text of size 1 and it's B, I'll go here, I'll subtract 1 from B, that was 1, that'll be 0 exactly. Then I'll get out here and I'll do min plus plus. Oh no, but it's balloon though. So maybe we won't, right? Because this will actually, you know what? Let's just return this. I'm like really confusing myself here. Let's see what this gives us. 0 and 1, so that one doesn't even work. This one's a tricky one. I didn't even get the test case right, the first one. Zero and 1. I should be able to do. I have 1B, I have 1A, I have 2 L's, 2 O's, and an N. For let I equals 0, I less than search.length, I plus plus. Index is search of I. which is b.carcode at 0 minus 97, if ban.test search of I, do I need to do something else here? Don't think so. Minus frequency at that index. Let me see if, I wonder if like this will work. I don't know if it's because of a regex thing. Maybe I'm not even creating the frequency right. Zero and one. Am I even looking at the right thing? I have text that gives me all the words. Now I just want to look for balloon. So I get balloon and I try to find the frequency of balloon inside of my frequency array, given that index, which is the B, which should map to 1. If minus frequency of index is less than 0, return min. Else if L or O IG test search of I, right? That should be L. And just let me just make sure that's right. Like regexer L and O, right? It should match O, right? Nothing else, just L or O. Okay. Now live streaming. Frequency index plus plus const of index. Can we I don't know if that's the best way of doing it, but BAL 1111. Okay, so we're getting, this is BA. Oh, wait a second. Maybe I don't need to do T2 here. I can still just subtract. I guess maybe I don't even need this other one, right? Maybe I just need, what if I just do this, remove this guy? Because I guess I'm still going to be doing the double delete anyway. Return min. Okay, remove this. Will this one work? Okay, 1 and 1. Again, I really don't think this is the most effective way. I can't wait to read the discussion because this is a pattern I struggle with, actually. Let me see what this is. Hopefully it's the right answer. Okay, 74.5. I don't like, I mean, how many times will this run? This loop will always be constant, right? It's never, there is nothing, like it's not dependent on the size of text. And this while loop will only run for however many instances of balloon there are in text. So we have the time complexity here, like this is O of n right here. This is essentially just amount of unique instances, however many instances there are. So I guess that's just O of min, essentially. O of min plus 1. It's going to run at least once. So I think this will just be like O of text length, and this will run at least O of min plus 1 times. And then space complexity here will just be constant, right? Now, let me run this again. So what's the pattern that I'm struggling with here? And we see this a lot where it's like we need to keep track of a count of individual letters or instances, but it's sort of the other way around, where instead of taking a frequency and then looping through frequency and subtracting letters, I feel like in this case we're adding them to see if we have like a count that matches the target word, if that makes sense. Hopefully it does. Okay, simple counts of cars. Okay, so I want to see what this person's talking about. Okay, so look, I think we were onto something for that first one, because we were definitely talking about minimums, right? So they're just creating a frequency. The minimum is cars of 1. over 2 divided. Wow, it's actually, it's the same thing. So like, why did I think that could not work? Because what happens if we get, if I only have a string of size B, of size 1, and I say that my minimum is cars of 1 for B, wouldn't this equal 0? That's like what my thinking is here. Are we not guaranteed? Maybe you know what? Text out length. Am I looking at the wrong thing here? Yeah, if they give me a B, what is, let me see something here. Zero and 0. So how does this one work? He's taking the frequency. He's saying the minimum is going to be cars at B, which would be 1. Oh, okay. We're still considering all the other ones. Okay. So yeah, we were onto something in that first one. Okay. So I mean, that it makes me feel good that at least we were on the right path, sort of, in the beginning, and then I think I just psyched myself out. I got to the point where I knew that it would be the minimum, but I didn't also consider looking at all the other characters as well. I think this is a nice solution. But at the very least, maybe you took something from this. I know it's not the best answer, but I'm okay with it. So I'm okay to move on. Reformat date. Oh no, I don't like dates. Given a date string in the form day, month, year, where day is in the set 1st, 2nd, 3rd, 4th, 30th, 31st, month is in this, convert the date to the string year, month, day, 20th of October 2052, day, month, year. Wait, but really? They just want us to do, so what if I split the date immediately? What if I do something like, okay, day, month, year equals date dot split it by the space. I think it says given dates are guaranteed to be valid. And now it wants you to return it like this, but just a little bit differently. So this can remain. Now, do I need to create my own mapping for this? I guess I do. Like the date can stay the same, and the day, let's see, it's gonna be th. Well, first will be this, second, and then we have third. Okay, let me see, 4th, 5th, 6th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th. So I mean, does just go all the way up to 20th, and then 21st, 22nd. Oh, 23rd. I think I see a pattern here. 24th. Okay, so there's some pattern here that we'll figure out. To be able to get month in the set, Jan, February, I guess we're just going to have to, I think for month, we'll just have to make a mapping. Okay, so let's do month map. And here I think we're just going to, we're just going to have to do Jan, Feb, Mar, April, May, June, July, August, Sep. We have Oct, 10, 12, 11, and finally December, 12. Sweet. So this will be our month map. We don't have to worry about the day, or rather the year. And then let's come up, and then it's going to be some formula for this. So if it's first, like anything that I guess ends with 1 will be IST. 21st, is that just going to be, let's see, it'd be nice if we can say like, if the number, I'm gonna come up with some crazy like thing here real quick. 0 modulo 10 is what? 0. 10 modulo 10, 20 modulo 10. So if it's like, if the number minus 1 modulo 10 is 0, will that work for those ST dates? And then second, is that just like if it's a modulo of, well, I don't know about 11, but third, what's the pattern here? 2-digit date. Oh, wait a second. 20. I don't need to do anything. I think I can just parse. Yeah, I can just parse the number. I can just parse the number. Yeah. I mean, is that like a cheap way of doing it? I hope not. I think here we can return. We're gonna do year, the month will be month map, right? Year, month, day. Oh, and they also want 0606. Okay, I see. So they also want padding. So these I should make all 0. Okay, here we can say parsed day equals parse int parse int of day 10 if parsed day is less than 10. Let's see. Let's do let string parsed day equals this. I can say string parsed day. I wish there was a nicer way of doing this. Month map. Let me just take care of this month real quick. That will be that. And then for my day, when do I add a 0? Only if it's less than 10. But how is it that I want to do this piece? I can say let parse day is the string of parsed day. No, I should still have this. Okay, here, this is what we'll do. If parse day is less than 10, I want to make it a string anyway. Parse day equals 0 parsed day and then here we can just do parse date. Now if I just make this a string, I guess I can make this a string immediately. I mean, this is just parsing. It's not very nice. Let me see what we end up with here. Any thoughts on why tech sales gets paid more than software engineers? Is that true? I'm pretty happy with the amount that I'm getting paid, and I feel like the sales engineers, I think what happens is software engineers get paid a lot early on in their careers, but maybe they top out quickly. Maybe sales engineers have more, I guess, face time with customers, and that's why they get paid more, perhaps. I don't really have thoughts on that, no. I'm guessing it's, if I were to take a guess, it would be because they spend more time in front of customers, perhaps. Okay, what's happening here? I thought my month map. So if I have June for my month and I look at June 06, that's not also, software engineers get paid like 100, 200. I've seen tech sales get paid over 200. Yeah, I mean, I guess it depends on the company and the technology that you're selling. Month map of month. Why are we not returning this? Does it want me? Oh, you know what? I know why. I guess for these, we can just do this. I think for the rest, we should be fine. This is, I don't know. This is kind of hacky. I'm not too in love with this, but let's see what this gives us. 40.49. This piece right here, there's got to be a nicer way of doing this. Like the parse day will be a string of parse int. If it's less than 10, we'll add a 0. I mean, I guess it's okay. Cool. I don't really like, I mean, it's cool that we solved it. I'm not like in love with the question. Simple and concise map. All right, they have their map here, and yeah, they pretty much did the same thing. They're adding a 0, substring 02. So very similar to what we came up with. So yeah, this is not really a great question though. You're not really learning anything here. By the way, I don't know if I've seen you before, Nelson. So thanks for joining the stream. Always good to have new people around here. Complement of base 10 integer. The complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to 0. For example, the integer 5 is 101 in binary, and its complement is 010, which is the integer 2. Given an integer, return its complement. Yeah, I think what we can do here. Oh man, this was like, yeah, I know what we can do here. And we recently did a question where we wanted to, like, if I have a 32-bit integer, let's say I have like all this and then 101, I can't just flip everything, right? Because then we'll end up with all ones here and then only some zeros here. So we came up with a way to figure out like how many ones what's the last place we'd have to go to. So what we can do, if I want to flip everything, what's the mask that I can do? If I do this by 1, that'll be 0, 0, 1 is 1. I can just XOR my mask, right? So I want to create a mask of a particular size and then XOR with that. Now, how do I generate that? Okay, yeah, this is what we're going to do. So we're going to say const generate mask, and it's going to take positions. Here we'll say let mask equals 0, and then we'll say for positions. So I'm going to do 2, 1. For positions greater than 0, positions minus minus, we'll do mask equals mask left shift by 1. Now to figure out how many positions, get, I guess, leftmost set bit given a number. Let position equals 0. Here we can say while num is greater than 0, we'll do position plus plus and num. Can we just right shift by 0? Is that how it works? And then we can return position here. Let me just see what we get. If I pass in 5, I would imagine that we should get 3, I hope. Console.log this of 5. I'm gonna explain all this in a bit if I'm going like too quickly, but look, it doesn't even seem like this is gonna work. Is this even a thing that we can do? Because I don't want to go over by 1. Does this just mean, wait a second. Maybe what I'll have to do, if I do a like 0 left 1. Okay, so it's not introducing a 1, it's just right shifting it. I see. Okay, S to T out 3. Okay, so this means that like for 5, the last 1 is in position 3. So now we can create a mask that's of size 3. And what we can do is inside of here, we'll set mask to 1. And now if I pass in, if I do console.log of generate mask with the position of the leftmost bit of 5, this should give me 7. Or nothing. Oh wait, return mask. Eight. So we might be. Is it too much to have? Should this just be greater than 1? Since I'm already starting at 1. One. I go left 1, but left by what? That's the piece that I think. Yeah, no. That's the piece I'm missing. I'm going left by 1, but I need to also just like. I need to push a 1 in there. So how's it that we do that? Generate a stream of 1s of set bits. Like generate mask of 1s bits to generate bit mask. Always 1 less than a power of 2 is the easiest way to get the nth power of 2. You don't want 0 to provide a bit mask. You want it to provide 0, so you need to subtract 1. 1 param minus 1. Is that really what it is? Well, I'm all over the place here. 1 param mask equals 1. What's the param? Like how? Mask equals mask to the left of 1. Mask 1 minus 1. That doesn't seem right. That's 1. 5. If I do a 0 here, what does this give me? And we've done this before too. That's the part that's like a little bit annoying, because we have done this before. That's still 1. And I make a bit mask that only max certain parts with the least significant bits. Generate a mask. Ugly example. Okay. I don't want any of these. Mask. Assign integer of -1. This could be shortened to. And what is param? Like, does this do it? If I have this and this is 3. Ah, look at that. That's beautiful. This is really nice. So we can actually just return this. Remove all this. Oh, and it was a -1? Ooh, I gotta look into that before I like. This would be position. I'll make this position. Generate bit mask. Get most set bit. So let's see. Should this give me? Okay, this gives me 7. Now I should just be able to return const mask equals generate mask of that. Now can we just return mask or num? Or n, not num. I know there's a different way of doing this piece right here. Okay, that's 2 and 2. This is a beautiful like bit manipulation trick right here. Two, 0, 13, and then 5. Okay, so we didn't get the last one. Generate mask. Oh wait, get leftmost set bit of n. 205, 205. There you go. Let's submit this. 001. If it's just 0, should it be 0? I mean, this is not. If n less than or equal to 0, return 0. This is a kind of a crappy edge case right here. Wait, what? Oh, expected 1. Okay. Input 0, and then I see. Oh, because this whole time we're looking for, it could be 0. So maybe if it's just 0, we just return 1. And it's only ever going to be 0. Let me just make sure before I lose my acceptance rate. Oh, wait, I click submit. 30.89. Okay. So let me explain this a little bit. So what I did was, like, in the beginning, remember that, like, they're only showing me 1, 0, 1 of 5, but if it's a 32-bit integer, again, you can imagine that it's a number that looks like this. If I XOR, if I create a mask, a 32-bit mask of 1, and I XOR this whole thing, this will be flipped in the correct way, but then all of these will become 1, and that's not what we want. I only want to mask the number that's as long as the input. So to be able to know, I need to know the last place that there is a 1. So at least I call it the leftmost set bit. And we can figure that out by constantly shifting this thing to the right. So if I introduce a 0, then we lose 1 at the end. Introduce another 0, we lose 1 at the end. And I'm doing this while this number is greater than 0. For example, it's still greater than 0, so I introduce another 0, take this one off the end, and now we know how many times I needed to shift this before there was no 1s. That's going to give me the size of the mask I need to create. Then we get to generate mask, which, using this very clever bit manipulation, I guess, construct, we're able to generate that mask. And then finally, using that mask, I can just do an XOR of the mask and the input. That's how I do it. I know there's another way of doing this piece right here. I probably just have to learn more about bit manipulation, but I would like to read about this a lot. I think it's pretty cool. What I'll do, I'm going to share this with you all. Let me sign into the chat. I'm going to send this here in case you guys want to see it. I think it's pretty cool. Good answer to look into. But that's going to wrap it up for today. We're just over the hour, about 8 minutes. Let's see how many questions we're out today. I think we did like 3. We did 4, so not terrible. I think, let me see, this last one I think was pretty good. I do like this one, so I'll add this, and I'll look at the other ones and figure out which ones I want to add. So again, remember, if you like what you saw, if you like what you heard, you like doing these problems with me, remember to subscribe to me on YouTube, follow me on Twitch, ring that notification bell if you want all the latest updates, and you can visit my website, rafaelslist.com, where we have, since the beginning, I've been compiling a list of all these top quality questions for you all to practice. You can even keep your progress. You can keep track of the questions you've done. There's links to all the different streams where we've talked about them, and I think it's just a new way to hold yourself accountable and approach your LeetCode practice. So with that being said, appreciate everyone that joined today. Hope you all have a great weekend, and I'll see you all tomorrow for our weekly roundup.